For expressions with unlike denominators, we're going to need to first get a common denominator. So in this example down here, add 1 over 12x plus 2 over 3x squared. We can see that these denominators are not the same. So the first thing that we're going to need to focus on is finding what's called the least common denominator, or LCD, and this is based on a principle called least common multiple, or LCM. These are really saying essentially the same thing. The only difference is context. You can have the least common multiple of the two expressions, 3x squared and 12x, or you can have the least common denominator of an expression that has those in the denominators. So the way we find this LCM is that we first start out by lining these up, at least mentally, by what factors kind of go together. Numeric factors go together. So the 3 and 12 I'm going to think about at the same time. And x squared and x are both powers of the same variable, so they also go together. For the 3 and 12, let's focus on those first. We want to find the least common multiple of 3 and 12. This is just like what we would have done back in the days of adding and subtracting fractions. If I take 3 and 12 both off to the side and I start writing down their multiples. 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12. In this case, it wasn't necessary to find any multiples of 12 because it turns out that the least common multiple is actually the value 12. So I stop as soon as I get a number that's common in both chains. So my least common multiple of 3 and 12 is just the value 12. Now I'm going to take these powers of x, and the way I find the least common multiple from two different powers of the same variable or the same variable expression is simply by taking the largest power. In this case, the largest power is x squared. So since x squared is the largest power present of x, that is what goes into our LCM. So the whole LCM is what I get when I put these two pieces together. 12x squared. And one way to think about LCM is that we would take all the rules we have for GCF and just reverse them. For the greatest common factor, we're generally going to end up with a number that is smaller than both of the numbers involved. The greatest common factor of these would be 3. And you're looking for the largest number that's a factor of both. For the least common multiple, we're looking for the smallest number that is a multiple of both. Similarly, with variables, the greatest common factor is the smallest power present. The least common multiple is the largest power that shows up in any of these expressions. So now we're going to go ahead and use this information. The least common multiple of these expressions is 12x squared, and therefore the least common denominator in this expression is 12x squared. Let's go ahead and now get ready to use this information to add these two rational expressions. First, I'm going to look at 1 over 12x. My goal here is to build up that LCD in the denominator. So I'm going to build up the denominator to have the LCD. I want 12x squared. I have 12x. So I can see that the only thing I have missing is another factor of x. So I'm going to multiply that denominator by another factor of x. I'm only allowed to do that if I also multiply the numerator by another factor of x. So that in effect, what I'm really multiplying by here is a ratio equal to 1. Now I'll do the same thing with my second rational term, 2 over 3x squared. I also want this to have 12x squared in the denominator, and in this case I can see that what I'm really missing is a factor of 4. If I had another factor of 4, that would bring it up to 12x squared. I can't multiply the denominator by 4 unless I also multiply the numerator by 4, so that again I am multiplying this expression by a ratio equal to 1. So that in both cases I am building up the denominator to have that LCD. Now if I go ahead and multiply across here and multiply across here, I can see that that first term then becomes x over 12x squared, and that second term becomes 8 over 12x squared. Now these are unreduced the way they appear right now, and that really is by design, so we don't want to ever start canceling common factors at this point. Sometimes people get a little bit too used to canceling common factors and they come through and reduce these, but they have what we want right now, which is the same denominator. So this is now a problem that we can proceed with in the same way that we handle a like denominators addition or subtraction problem. That means that we are ready to now perform this operation, which is addition. So this tells me I am going to add the numerators. And we want to be sure that we're really paying attention to our rules for adding like terms. X and 8 are not like terms, so when I combine these and I add those, I'm not going to actually get to combine them into a single term. I just get to write it as addition in the numerator. X plus 8 is simply x plus 8. There's no way to combine those, but I do now have this over a common denominator of 12x squared. It's not possible to simplify this any further. We don't have any common factors on the top and bottom. Remember that we can't take 4 out of that 8 and 12 because 8 is an added term in the numerator of this expression.